Today's topic is mechanical weathering. It's the physical breakdown of rocks into the smaller pieces without changing their chemical composition. It's the breakdown of rock into different size and pattern. It's related to the energy. Energy is solely related to the weather phenomena. This is the lithosphere. It's the surface and up to some depth, that is the subsurface layer of lithosphere. And it's the atmosphere. The zone of weathering is the zone of interaction of climatic as well as the weather phenomena to the lithosphere. The effect goes on the surface and subsurface layer of lithosphere, and there is change in size and pattern of the rocks. In the few rare cases, the zone of weathering also related to the interaction zone of lithosphere, atmosphere, and hydrosphere, rather the adjacent area of coast or ocean surface. This type of mechanical weathering occurs due to the intrusion of saline water. Controlling factors of mechanical weathering. First one is the climatic factors or weather attributes. It includes rainfall, humidity, wind motion, flowing water, and glaciation. It's related to the seasonal and diurnal phenomena, alternative wet and dry period, and season change. Second one is the lithospheric attributes. It includes nature of rock and minerals, crack joint fault in the rock bed, and sensitivity of rock in heat and water. Both attributes related to the time scale. On the basis of pattern or the shape, mechanical weathering classified as square, block or rectangular. Second one is circular or round. Third one is granular. Fourth one is sheet, and last one is wedge. Square, block or rectangular is related to the vertical and horizontal cracking. Circular and round is related to the round shape or circular shape. Granular is related to the small size of grain or nodules. Sheet is just like a layers, and wedge is elongated in shape. Types of mechanical weathering on the basis of energy. First one is the wind. Second one is the heat or thermal condition. Third is surface runoff or water. And fourth is snow, frost. Types of physical weathering. Physical weathering due to wind, due to thermal conditions, due to surface runoff and water, and glacier and frost. These are the basically four types of physical weathering. Another important type of physical weathering, that is the fifth one, is the salt weathering. It is very common in the coastal region. It occurs due to the intrusion of saline water. The wind and thermal weathering is common in the arid to semi-arid climatic region, and physical weathering related to water and the surface runoff is very common in the tropical to humid climatic region, and glacier and frost related mechanical or physical weathering is very common in Arctic to subarctic region and the hilly region or the mountain region. These are the basically five types of physical or the mechanical weathering. Mechanical weathering by the wind. The two process, friction and abrasion, is very important here. Strong wind carry the small particles of sand. Eventually, when the wind velocity decreases, there is a falling of the rocks or the sands or the sand particles on the bedrock or the surface. There is a frictions, and it acts like a natural sandpaper, and there is breaking down of the sand to the smaller sand particles or the dust to very smaller dust particles. This is the way most of the desert full of very tiny sand particles due to the mechanical weathering by the wind. It's the explanation of the exfoliation process. This is due to the day and nighttime temperature variation and the subsequent thermal gradient and its direction. It's the core, it's the daytime fact. The core is there is a low temperature and high temperature in surface. There is a temperature gradient from the surface to core in daytime, and reversal situation occurs after the sunset. The surface of the outer surface of the rocks gets cool, and the core is still with the high heat. There is a temperature gradient from the core to the outer surface. This reversal temperature gradient is responsible of breaking of the rock, and rock disintegrated or weathered through the layers of concentric ring. So it is called as a exfoliation. These are the example of thermal expansion. This is a local example, Mama Bhagne Pahad, and that is Sikra Pahad, Purulia, and Joychandi in Purulia. This is the example of block disintegration. It's the example of exfoliation. It's the example of granular disintegration. Thermal expansion, there is a lots of significance in landscape. In the arid to semi-arid climatic condition, the bonebirds, inselberg, falsenmeer, and talls, sand, pebbles, cobbles, all are related to all the landscape and the subsurface and surface land configuration related to the mechanical weathering, rather thermal mechanical weathering. Mechanical weathering due to running water or the water. There are two types of that kind of weathering: hydrofracturing and cracking of the surface layer. This method is very common in the humid to subhumid climatic condition where the alternative wet and dry periods come simultaneously. During the wet months or monsoon, uh, rocks absorb moisture or the water, and there is a swelling of rock. And during the hot summer, due to hot summer and evaporation, water evaporates from the surface layer of the rock. Alternatively, contraction and the swelling of rock bed due to humidity. There is an extreme strain of the rock bed and there is a breaking of the rock. This is very common in the humid and subhumid climatic condition. It's a picture of Gautam Dhara, rather Junafal of Jharkhand. That kind of hydrofracturing is very common. Second one is the cracking of surface. Subsurface layers absorb moisture or the humidity during the humid seasons, and during the scorching summer there is evaporation of the humidity and it becomes very dry, and there is a square grid or hexagonal grid type of breaking of the subsurface layers, and that kind of water related weathering is known as cracking of surface layers. Fourth one is the frost or the glacier related mechanical weathering. It is very common in the hilly or mountainous region or the region of Arctic and subarctic region. Normally, there is an alternative wet and dry period, and during the summer, water percolates the cracks of the rocks, and when the winter comes and it's water converted to the solid state, and there is an expansion of volume, and due to intense pressure, there is a breaking of the rock. This process is known as frost wedging. It is very common in Himalayan region, mountaineer region, Arctic to subarctic climatic region. Atul Tunnel and the Amarnath Cave at the its crack zone is an example of that. Frost wedging related to the alternative freezing and thawing of the water, and result is that the breaking of the slope. And it's the Amarnath Cave. It's a perfect example of the frost wedging. Here I would like to mention one thing. We are all familiar one of the glacial structure, that is Roche Mutane. Before Roche Mutane, there is a cracking of the rock bed. That cracking of the rock bed is related to frost wedging. Frost wedging is the precondition of the formation of Roche Mutane. Last one is the salt weathering. It is also caused as a halocusty. And salt weathering is very common in the coastal zone. Saline waters enters the rock pores and cracks, and as the water evaporates, the salt crystal grow and exert pressure, causing the rock to weak and the breakdown. This method is very similar to the frost aging. It's related to the saline solutions. And honeycomb stone taphony, that is also called as a hat rock. It's a photograph of Carolina of USA in the Atlantic coast, is the common example of that. This feature is typically developed in the porous granular rock, even in the sandstone, and granite, even in the sandy limestone. And taphony is very common in the coastal zone. Glimpses of landscape of mechanical weathering. It's the cracking and breaking of the rock due to humidity and the temperature near the Rachi. It's the exfoliation near the Rachi. It's the Sri and Talus near the Dunka. It's the example of torts near the Dunka. It's the block disintegration Mavabhagnehi. It is near the Karnataka balancing rock. It is the spherical or the granular disintegration near or the Joychunti hill of Purulia. The landscape, rather subsurface and surface landscape of lithosphere, is shaped by the weathering process. It's the most famous and wandering example of weathered landscape. It's the Hoodoo's Bryce Canyon of Utah province of USA. These are the glimpses of that Bryce Canyon of Utah province. It's formed through the millions of years. It's the combination of frost wedging, thermal weathering, and the water. And it is the most wandering landscape of subsurface and surface, rather the lithosphere. That landscape is shaped and formed by the weathering. Hoodoo's Bryce Canyon of Utah, USA.